Carrie Roberts here, and today we're going to talk about MITRE ATT&CK technique called event-triggered execution. We talked about this last week too, but it was a different sub-technique. Last week we looked at NED-SH helper DLLs. This week we're looking at accessibility features. So event-triggered execution is something that allows attackers to schedule something to run when something else happens, when another application starts. In this case, when somebody accesses or runs an accessibility feature. Windows has accessibility features built in, such as an on-screen keyboard or magnifier that you zoom into a certain part of the screen, or the sticky keys functionality, which allows you to be able to push key combinations like Control-Alt-Delete without having to hold all three keys at one time. So it's like they stick on. You push Control, you can let go, push another button, and it acts the same as if you were holding Control and the other button. So these can help people that are impaired to use computers. And also there's an on-screen narrator that will read the screen to you. And what's really neat about the accessibility features from an attacker standpoint is that they can be used from the login screen. So without even logging into the computer, you can access the computer. If you can cause your malicious code to run because accessibility features get launched, then that can be really powerful. And that's what we're looking at today. So we're going to jump over to the Atomic Red Team library, scripted cyber attacks. Here we are in Atomic Red Team. We've jumped into the Atomics folder, and we're looking at technique 1546, sub-technique number 8. That's what MITRE defines here, 1546, sub-technique number 8 here. So in Atomic Red Team, we're looking at the markdown file, which is the friendly human readable version of the test. At the top, we have copied in from MITRE ATT&CK the description. And then we see a list of the atomic tests that are currently scripted for this technique. And there are two of them. One that attaches a debugger, one of the accessibility features. And so what's really cool about this option is that it doesn't affect the normal use of the accessibility feature. So the magnifier is still going to work. The on-screen keyboard is still going to work. But in addition to the accessibility feature running, it launches another program which Windows is assuming is a debugger to help a developer debug a problem with their application. But in this case, for an attacker, it would be their malicious code. So it's a very stealthy way to abuse the accessibility features. The second option here is to replace the binary of this, in this case, of just one of the accessibility features, the sticky keys. So this would cause sticky key functionality to no longer work. Instead, when somebody launched the sticky key feature, it would run whatever the attacker had defined or replace that binary with the executable. So let's look at test number 1. We have some input arguments here. We have a list of executables. These are all accessibility executables. We have the osk on-screen keyboard, sethc.exe. That's the sticky keys functionality, utilman.exe. That's the little graphical user interface that pops up where you can turn accessibility features on and off. We've got the magnifier, which you've probably seen. You probably accidentally hit the key combination on Windows to make that come up. It'll zoom into a part of the screen. The narrator, which will read the screen to you. And then there's some display switchers, like when you press Windows P, you get that menu to change what your display is, that are also available as accessibility features, and then the app switcher. So this atomic test actually, since it gives this list of executables, it's going to attach a debugger to all 7 of these. And the debugger it's going to attach is whatever is defined here as the attached process. The default is to just attach cmd.exe, very versatile option for an attacker to just launch command.exe and then to use that to accomplish their task. So here we have some PowerShell. It says that we need to run from elevated context. It looks a little bit confusing just because it's looping through all 7 of those items. But really, we're just looking here and seeing that there's a registry key being made image file execution options. That's how you attach a debugger. You just put the name of the executable you want to attach to here. So this $item ends up being each of these 7 items. So it's going to create one called osk.exe, setHC.exe. It's going to create that key, and under that key, it's going to create a debugger. So this name here, debugger, is going to go in here as the name of that registry key, and the value is going to be the attach process. So this hashtag squiggly is going to be replaced by Windows System 32 cmd.exe. And then whenever any of these programs is launched, the command prompt will come up, and that can be done from the login screen. So we could copy this out of here and paste it into PowerShell ourselves, but then we'd have to do a little work to it to replace some of these variables, so the attach process and parent list. Instead, we'll use the execution framework called Invoke Atomic Red Team. It's a PowerShell tool that knows how to follow the directions in this library, replace variables, and run things for us. So I've already got Atomic Red Team installed, so I'm going to bring up an administrative PowerShell prompt. Right-click on PowerShell and click Run as Administrator. And then I'll say invoke atomic test T1546.008. And then first I'll just show the brief details, because that tells us the name of all the tests we're looking at. Yep, it looks like we're on the right one. We have the 2 tests we talked about. So we're going to start off by executing test number 1, attaching debuggers. But for this example, I don't want to do all 7 at once, because I want to take it a little slower for the demo. So I'm going to add in an option with Invoke Atomic Red Team to say prompt for input arguments. And this lets me change those default values. So here it says enter a value for attached process. So the attached process is by default is command.exe. So if I want to change that, I could type that in here and it would use that. Instead, I want to use command.exe. So I'm just going to press enter to accept that default. And here's the one I want to change. Instead of doing the whole list of osk.exe, setHC, utilman, magnify, I'm going to just type in 1, osk.exe. So we're going to replace the on-screen keyboard. So I go ahead and press that, and now it's running the test. It's setting that, it's creating a registry key, osk.exe, but we get Windows Defender popping up, and Windows Defender has found an accessibility escalation is what it called, and it removed it. So actually, if we were to go check this registry key that we think we just made, image file execution options, osk.exe, and we added a debugger key, it'll be gone. So Windows wiped that out. So Windows Defender as an AV is doing a good job of blocking that attack vector. We could run an additional one. Actually, if we go down through all 7 of these, all 7 will be blocked in the same way. So I won't drag you through that. I've already done that. But then we put our offensive security thinking hat on and say, well, what is Defender really looking for? Maybe it just doesn't want command.exe to be added as a debugger, but maybe you could add something else. And in our case, we want to add something that still gives us command execution. One option for that might be ftp.exe, a built-in FTP tool signed by Microsoft in the same directory. So let's try that. So when we prompt for input args, we're going to say C Windows System 32 and then ftp.exe. And this, let's try to do the set, or we'll do utilman.exe. See if we get a Windows Defender pop-up. We don't see anything. So now let's see if we can actually use that. So it looks like Defender, like command being set as a debugger, but ftp.exe is fine. Let's lock our screen here. And this is what's really neat about this attack vector is that you can access, let's say, the command prompt or ftp.exe from this login screen. So even when nobody's logged in, so if an attacker's got RDP, can reach this system via RDP, they can get to the login screen, and then they can bring up the accessibility feature that they've hijacked to run their code. So here, this little ease of access is our accessibility feature menu, and the menu is what gets launched when you start utilman.exe. That's the thing we just hijacked. So when I press this button, it's going to run utilman.exe, and at the same time, it's going to start up. See that it started up a little command prompt, and if we could have read it that fast, we would have seen it started saying some stuff about FTP. So it actually is running ftp.exe, but then it disappeared, and we don't really get a hint why. So let's press this accessibility button again to run utilman.exe, and this time it works. So actually what we find out when we log in is Windows Defender actually, even though it let us set that, just a minute, I can't talk and think at the same time. So it actually gets blocked. So if we go, there'll be a newer threat found just from, let's see, 408. So 407, a threat removed, accessibility escalation. Oh, I don't know what the O stands for, but it's different. It's blocking that at the time that we actually exploited it, the time we tried to run our debugger. So we got a little further by setting it to ftp.exe, but we didn't get all the way there. There's a great write-up actually from 3 years ago on the Trusted Sec website by Oddvarmo, and this is playing with old hacks. So this definitely is an old hack, but it's so powerful that as offensive security practitioners, we really try to get this thing to work. Attackers also are interested in getting to work. So in this blog, he's interested in getting this to work for a demo. So he goes through and he tries some different things. He talks about trying ftp.exe. And in fact, when he ran it, there were a few cases. He's got a little table in here where it actually did work. FTP worked with sethc. I didn't find that to work when I tested it last week. But there's also some interesting stuff down here where he points out there's another way to do this exploit, which is to, instead of replacing the binary, which we haven't played with that atomic yet, but instead of replacing the binary, we can make a symbolic link. So that says, hey, when you try to run utilman.exe, actually just go over and run command.exe. So we're going to play with that too. But first, let's go back to our atomic tests here. Remember, we had test number 1, attaching a debugger. We really liked that idea because it didn't affect the normal use of the tool. But we saw that Windows Defender was shutting us down on that. So let's move to test number 2, actually replacing one of those binaries. So instead of actually running, in this case, the sticky keys binary, we're going to replace it with the code we want to run. So here we'll say run test number 2. We'll see if Windows Defender doesn't like anything about that. Seemed to have worked. Let's go back to see if it actually works by locking our screen. And to bring up sticky keys, I can press the Shift key 5 times. And here we have sethc, the sticky keys binary. Well, it's not actually running the sticky keys binary. It's running command.exe, which we just replaced sethc with. So here I am at the login screen. I haven't logged in yet. So if I was an attacker having come back to this machine after compromising it before, I could just press the Shift key 5 times. I could get this pop up. If I say, who am I find out that I'm NT Authority System, which is even a step above an administrator of a computer. So with this level of access just from the screen, as an attacker, I can do anything I want to this computer. I could change the password of the current user to something I pick so that I could log in. I could add new users, but most likely an attacker would just use this command shell to download some other code to run to give them command and control, or C2, access to this computer. So running some code that would let them have full access to anyone who's logged in and run any commands they want. So that's the danger of this attack and what we want to prevent. So I'm going to log back in here. So let's take a look at the details of that test, just so we know what we just did. So in test number 2 here, we just made a backup copy of set.hc, which the attacker may not do, but we wanted to be able to clean up after ourselves after we run this test, so we do that in the atomic. So we have to do some tricky business with ownership and permissions, because the set.hc is owned by something called the trusted installer. So we, even in the administrators group, can't change it unless we take ownership of it and give ourselves permission to change it. So you see some commands to take ownership of the file and to give us administrators full access over that file, to delete it, actually, because we need to delete it before we can put a copy of, here we are copying command.exe to a file called set.hc.exe. There's also some cleanup commands, which what that's going to do is take our backup copy and put it back. So then we get our sticky keys binary back. So now that we're done playing with that, we saw that it works. So definitely that's something that would be a high priority to look at from a detection standpoint, because it's not blocked by default, at least by Windows Defender. So we're going to run cleanup. And now if I push the shift key 5 times, we get the normal sticky keys popping up asking if we want to enable that. We won't do that right now. So now we're back the way we were. So I thought it was really interesting on this blog post where they talked about just making a symbolic link instead of actually copying cmd.exe into a file called, in this case, utilman.exe. So I wanted to try that, and I really wanted it to be automated, because then I can script it and run it over and over again. So for that, I actually made a new atomic. So here's what a new atomic looks like. You've got, in line 1, you just give it a name. Here we give it a description. We say it's for Windows, because Atomic Red Team has tests for Windows, Linux, Mac, cloud, containers. And so we need to specify what this atomic is suited for. It wouldn't make sense to do this attack on one of the other operating systems. And then we have our list of commands here, and we have our list of cleanup commands. So we have to do the same thing here. We're going to make a backup, in this case, of osk.exe. We're making a backup copy. We're going to take ownership of it and give ourselves the rights to delete osk.exe, because we can't overwrite that with our symbolic link. We have to delete it first before we can create our symbolic link. On line 11, we delete osk, the real one. And then line 12, we make a symbolic link, which just tells the operating system, hey, if you want to run osk.exe, just go ahead and run command.exe. And then the cleanup commands get a little ugly. You don't really need to understand that fully, but it's just setting all the permissions back, putting that backup copy back for osk.exe, so you can use osk.exe normally. And we have that all automated. So now that we have this new atomic, all we have to do is tack it onto the bottom of that T1546.008 YAML file from Atomic Red Team. So here we are at the bottom of that. I'm going to paste in this new test. Now we'll go whoops, we'll go back here and we'll say, show me all the tests again, show details brief. And now there's a third test, create symbolic link from osk to cmd.exe, because we're really interested to see if this is also going to work. So before I do that, I'll bring up osk.exe. So this is the on-screen keyboard. And now I'll say run test number 3. We'll see if Windows Defender pops up. And it didn't. And we get a message that osk.exe is now a symbolic link to cmd.exe. Let's go back to our lock screen. And we'll use the accessibility feature button here. And we'll turn on the on-screen keyboard. And we get, instead of the on-screen keyboard, we get another system level powerful prompt, allowing us to change anything we want on this computer, give ourselves access. So that's the beauty and also the scary thing about the accessibility features and how they're abused. And it's clear that not all the venues are blocked automatically for us. So there's defensive work to be done here. Okay, now that we made this awesome new atomic test, we would like to share that with the community through Atomic Red Team, because then others can easily test the same technique in their environment. So I'm going to copy these lines, 65 through 88, our new atomic test. I'm going to bring up Atomic Red Team Online. Actually, we already had it here, but we're going to go to the YAML version because that's the official source of atomic tests. The Markdown is just an easy to read version of that. So here's all our atomic tests. We recognize this YAML format, sort of. We see the other tests here, and we want to add our tests in. I'm logged into GitHub, which is why I have this option this pencil option to edit the file. And it gives the impression that we're actually editing this file in its current place, but really we're just editing a copy of it, and we're going to propose to the maintainers of Atomic Red Team that they accept this change. So I'm going to go to the bottom of this YAML file. So those are the first 2 tests, and I'm going to, I'm going to paste in our new, let's see, I don't think I can make that more visible here. So we have create symbolic link from osk to cmd.exe. So then I want to propose a new change. I'll probably just use the same name for our change. So what this is doing is creating a pull request is what GitHub calls it. It's a strange name to me. It's more of a request that says, here's some changes, please accept them if you like how it looks. So I'm creating a pull request here. So I'm going to say propose changes. And here I could say the details of what testing I've done and stuff. I'm going to leave a blank just for speed here. And down here, it shows us what we changed. So it shows that we added all these lines at the end. This is a good thing to check when you're making a contribution to Atomic Red Team, and just make sure you're not getting rid of something you didn't mean to by accident or adding something. So everything looks good. I create the pull request. And now if we went back into that file on Atomic Red Team, it wouldn't have our new test, but there's a copy of the changed version here in our pull request. And we can see what we're proposing here. We're proposing this new test be added. And so then a maintainer can come in here and they can approve this and then merge that into the public project, making that part of the library. And so that's how you contribute and give back to Atomic Red Team. That's what I have to demo today. Please join me next week if you're interested in more details about Atomic Red Team and all things attack emulation tools related, you can join me in my attack emulation tools course from Antisyphon.